Welcome to Rise Up Namibia. So in this video, we're going to be looking at Indices Part 1, which involves the first three laws by Met Yanata, aka the resistor of bad and the lover of good. Hashtag dark and lovely _ walk by faith and not by sight. So without further ado, let's get in. Now before we start with indices, I would like to point out that we'll be dealing with numbers that are in exponential form. Okay, now what does it mean in exponential form? Let's rather explain this using numbers. So for example, this 5 and then the small number 3 here. This means they are in exponential form. Okay, so this 3 is called an exponent, or as some books will say, an index. Okay, now the 5 is called a base. The 5, which is the bigger number. Okay, so now what do they mean? What does a small 3 mean when it's on top of the, or next to the larger one, which is the base? Remember, this is the exponential notation, like the exponential form notation. Okay, so this small number, which is the exponent, simply means that 5, which is the base, is multiplied 3 times by itself. Okay, to explain this, let's rather bring this out. This simply means this. Now to prove to you, you can type this into your calculator. What's 5 multiplied by 5 multiplied by 5? It will give you 125. Now if you type again into your calculator 5 raised to the power 3, it will still give you 125. So the exponent simply means the number of times a number is multiplied by itself. Okay, good. Now let's look at this number. Now we have 25 raised to the power 2. Now which one is the exponent here? Remember, the exponent is always the smaller number on top. Okay, which one is the base? It's the 25. Okay, so the 25 is the base and the 2 is the exponent. So what does this mean? This together means 25 is multiplied by itself 2 times. Okay, so like this. So just to prove again, 25 times 25 gives us 625. And if you type this into your calculator, 25 squared or 25 raised to the second power, it also gives you 625. Okay, now with that out of the way, let's look at the first law of exponents here. So we have the multiplication law. Now the multiplication law states that if you have a number multiplied by another number, or let me rather say, if you have a base that are the same, two bases that are the same, that are multiplied, what do you do to them? You add the exponents. In this instant, our exponents are a and b. Now the bases are m, okay, which means they are the same. So we add a and b. If you don't understand this law, don't worry. We will get into examples that will enlighten your understanding, okay? So let's look at this example. What do we do here? Number one, ask yourself, are the bases the same? Look at this base. What's the base here? The base here is x. What's the base here? It's also x, meaning the two bases are the same. Now what does the law say? The multiplication law, because here we have a multiplication sign, we use this law. Multiplication law says that if you have the same bases, you need to add the exponents. So what are our exponents here? We have 4 and we have 3. So we add the 4 and the 3. So what is 4 plus 3? We get 7. So our answer will be x raised to the power 7. Okay? Let's look at another example. How about when you have numbers? So in our first example, we used variables, or let me say letters. But now in our second example here, we are using numbers. Okay? So we have 3 raised to the power 4 multiplied by 3 raised to the power 5. Now always look at the law and ask yourself, are these two bases the same? Yes. This 3 and 3 is the same. So what do we do when the bases are the same? We add the exponents. So what is 4 plus 5? It's equals to 9. Okay, so 4 plus 5 gives you 9. And then what is 3 raised to the power of 9? Or raised to the 9th power? It gives you this answer, which is 19,683. Okay? Let's look at another example. Now, what if you are given not only a variable or a number, but in this instance, you are given a number and a variable. Okay? So what you do is this. First of all, the easiest way you can do this is to first focus on the number part. So let's just ignore the letters. Okay? Now if you ignore the letters, you are left with like 3 multiplied by 7. Now when you look at the law, what does the law say? The law says when the bases are the same, that's when you add the exponents. Now when you look at 3 and 7, are those two bases the same? No, they are not the same. So what do? You multiply them. You look at the sign in between and you carry out that sign. So in this instance, this sign is a multiplication sign. So we multiply. What's 3 multiplied by 7? It's 21. Okay? So now that we are done with the number part, now we can focus at the letter part or the variable. Now when you look at this variable or this letter, we have A on this side of the multiplication sign. Now on the other side of the multiplication side, we also have A, which means these two bases are the same. Okay, the A's are the same. What do we do to the exponent or to their exponents? We add them. Okay, so these two bases, what are their exponents? It's 2 and 5. So what's 2 plus 5? Sorry, 2 plus 5 is 7. Okay, and just like that, you have found your answer. So let's look at another example. Now what if you have a number and more variables or more letters? You do the same thing. To make it easier, you can simply again ignore like the letters for now. You know, you can always first ignore the letters and then you look at the number part. Now when you look at the number part, are the bases the same? Now one person might argue that, why are you calling this a base? Or let me say this 3 a base when it doesn't have an exponent. Now one thing that I would like to make clear to you guys is, every time you see a number, that doesn't have an exponent, it means their exponent is 1. Okay? Even if it's this 3, it means the exponent here is 1. The 7 also, the exponent is 1. Now to prove to you that their exponents are 1, you can type it into your calculator. You can type 3 raised to the power 1. It will always give you 3. If you type 7 raised to the power 1, it will give you 7. Even if you type 300 raised to the power 1, it will always give you 300. So meaning any number that doesn't have an exponent, it means the exponent there is 1. Okay? So now let's get back to this 2. Are these two bases the same? Let's just add a 1 as well here. Are these two bases, the 3 and the 2, the same? No, they are not the same. So we cannot add their exponents. So what do? We look at the sign in between and we carry out that operation, which is multiplication. So what is 3 multiplied by 2? It gives you 6. Okay? Now once you are done with the letter parts, and then now you can focus on the letter parts, because now you are done with the number parts. Now you are done with the number parts, so you can focus on the letter parts. So now let's look at this left hand side of the multiplication sign. We have a A. Now on the other side of the multiplication sign, do we also have a A there? Yes, we have a A over here. Now are those two bases the same? Yes, this base A and this base A are the same. Okay, so what do we do when the bases are the same? We add the exponents. So what are the exponents of A? We have 2 here and we have 5. So what is 2 plus 5? It's 7. So we'll get a raised to the power 7. Now when we look at this side of the multiplication sign again, we have a B. Okay, so we look on the other side of the multiplication sign. Do we also have a B there? Yes, we have a B as well. Now, what is the exponent of this B? Remember what I told you earlier. Each time you see a letter without an exponent, it actually means that the exponent is 1. Okay? So, when we are adding these two exponents, we will add as 1 plus 4, which will give us 5. So the B will be B to the power 5. Okay? Now, once you look at this side, you have exhausted all terms on this side. But once you look at this side, there is an extra C there, which is not on this side. So what do we do with that C? We just bring it down the way it is. And just like that, you have found your final answer. Okay? Now let's take a look at another example. So what do you do when you have something like this? In this instance, we have like 3 parts. Like the first part multiplied by the second part multiplied by the third part. So what do? First of all, let's focus on the number part. Let's again take our focus away from all the letters, because I know a lot of people get confused because they focus on the letters. Now, I just want to point out something. This last term, there is no number, okay? Which means if there is no number and there is only variables or letters, it means that the number in front is always 1, okay? So let's cancel out the letters as well. Now when you look at the numbers only, you have -2 multiplied by 4 multiplied by 1. Okay? Now, are those bases the same? No, they are not the same. So what do? We look at the sign in between them and we carry it out. So what is -2 multiplied by 4 multiplied by 1? It's equal to -8. Okay? And now that you are done with the number part, now you can focus on the letters. So now we start with the letter A. So in this part, we have A here. Okay? Now when we look at this part here, do we also have an A here? Yes, we do have an A there. Now we go again and we look at this part. Do we have an A here? Yes, we also have an A there. Now, it tells you that this a's, all those bases are the same. So what do we do when the bases are the same? The multiplication law states that we add the exponents. So what is this exponent? It's 2. And then this exponent, because there is nothing written. Remember what I told you, when there is nothing written, it means the exponent is 1. Okay? So we say 2 plus 1 plus 3. Okay? So 2 plus 1 gives us 3 plus 3 gives us 6. So it will be a raised to the power 6. Okay? Now when we look at b, this side we have like a b over here. Now we look here, do we also have a b here? No, we don't have a b there. So we leave it and then we check here. Do we have a b here? Yes, we have a b over there. So now, because these b's, the bases are the same, let's look at what the multiplication law is saying again. We add the exponents. So what are the exponents of b? We have 2. Then this b has no exponent. What does that mean? That means the exponent is 1. So we have 2 plus 1 gives us 3. So it will be b raised to the 3rd power. Okay? Now, the letters, you are done with like a, b. But like if you look in the middle here, we have like a x. Okay? Raised to the power 2. Now in the other terms, there is no more another x. So you bring that x raised to the power 2 just the same way it is down here in the answer. And just like that, you have found your answer for this question. Okay? Now let's look at the second law, which is division, the division law. Now we're going to keep the notes here for exponents, okay? Like what the exponent is, the base, and everything. So now when we look at the division law, what does it state? It states that if two bases are the same, we minus their exponents, okay? Now remember the previous law was the multiplication law, which means it only applies if you have a multiplication sign. Now in this instant, we are approaching the division law, which means this one applies when you have a division sign in between your terms, okay? Now to explain this law, let's look at some examples. So we have 5 raised to the power, we have x as a base raised to the power of 5 divided by x raised to the power of 2. So what's the answer? Now when we look at our law says if the bases are the same, of two bases that are like being divided, if they are the same, we minus their exponents. So is x and x the same bases? Yes. So what do? We minus 5 minus 2. What do we get? 5 minus 2 is 3. So we'll get x to the power 3 or raised to the power 3. Okay? So let's look at another example. How about when you have numbers? Because now again here we started again with letters, okay? Or variables. Now what about when you have numbers like 3 raised to the power 6 divided by 3 raised to the power 2? Now what you need to keep in mind again is what the law is saying, the law of division. The law of division states that if the bases are the same, you minus 6 minus 2, which are the exponents. So what is 6 minus 2? 6 minus 2 will give you 3 raised to the power 4. Now you cannot leave it as 3 raised to the power 4. Like when you simplify this, 3 raised to the power 4, you get 81 as your final answer. Okay? Now you find some people might argue that, how did you get to like 6 minus 2? Now let's just quickly write it in fraction form. Now what I wrote here is the same as this. It's like 3 raised to the power 6. Remember when I told you that the law means, like the exponent means, it's the number of times that the base is multiplied by itself. Like this 3 meant 5 is multiplied by itself 3 times. Now it's the same here. 6 means 3 is multiplied by itself 6 times. That's why we have 3, like 1, 2, 3, 4, 5, 6. Okay? Now, divided at the bottom, this 2 means 3 multiplied by itself 2 times. So that's why we have 3 multiplied by 3. Now, what we did to subtract is we cancelled. You see, now when we cancel the first 3 on top, you need to make sure it's accounted for by a 3 at the bottom. So you cancel one 3 on top and you cancel another at the bottom. Okay? Now, when you cancel the second 3 on top, you also cancel it a second 3 at the bottom. Now, before you cancel the third 3, is there another 3 at the bottom, like a third 3 available? No, which means your answer is this one. These 3s that are left. How many 3s are left here? 1, 2, 3, 4. Now, if you multiply 3 times 3 times 3 times 3, what's your answer? You will still get a 81. Okay? So that's how we got this 81. In case this was a bit too complicated. So now, let's look at this example where we have the division law, but now we have a number and a letter like together. So what do we do? So the answer here would be 2a to the power 3. Now, how did I get this answer? What you can do is, number 1, focus on the number part. The number part is 6 and 3. So you can basically divide 6 divided by 3 will give you 2. And a is like bases. These two bases are the same. So you minus 10 minus 7 will give you 3. That's why we have a A3. Okay? Now to make this more clearer, you can always write it in this form, which is like in fraction form. So you write your 6a raised to the power 10 divided by 3a raised to the power 7. Okay? Now, once you write it in this form, you say 6 divided by 3. What's your answer? It will give you 2. And then you say 10 minus 7. What's the answer? For A, it will give you 3. And that's your final answer. So 2 methods, same answer. Okay? Let's look at this example. Now this answer as well is 4a squared b squared. How did we get this answer? Simply by looking at the number part first, by saying 20 divided by 5 gives you 4. And then if you look at a, it's raised to the power 3, and this a is raised to the power 1. So 3 minus 1 will give you a 2. And then if you look at the b part, 4 minus 2 will give you 2. That's why we have b squared. Now to make it easy, you can always write it as well, like in fraction form. So you say 20 divided by 5 will give you 4. And then a 3 minus 1 will give you 2. Now for the b, you have 4 minus 2 will give you 2. Okay? And this is your final answer. So again, 2 methods, same answer. So let's look at the last law for this video, which is the power law. Now what is the power law? Now the power law states that when you have a term or a base and an exponent, like let me say if you have a base and an exponent, and again it's raised to a certain power, you multiply the two exponents. Okay? If you don't understand this law, don't worry, we'll get into examples that will enlighten your understanding. Let's take an example of m raised to the power 5. Now remember, this m is the base, while the 5 is the exponent. And then again, it's raised to the power 2. So what do we do? Now the law states that you multiply b to a. So what is our b here? Our b here is 2, and our a is 5. So we multiply 5 multiplied by, 2 multiplied by 5. Okay? And that gives us what? That gives us 10. So the m stays the same, and then we have 10. Okay? Let's look at another example. So the first example was with a letter. Now the second example is with a number. So how about when you have 4 squared, or 4 raised to the second power, and then again it's raised to the second power. So the law states that you multiply b by a. So what's our b here? Our b is 2, and our a is also a 2. So we multiply 2 times 2 gives us what? It gives us 4. So our answer will be 4 raised to the power 4. Okay? Now remember, when it's a number, you can't leave it like this, like when it's a variable or a letter. When it's a number, you need to simplify it. So what's 4 raised to the power 4? It's 256. Okay? In case you are wondering where we got the small 4, we got this small 4 by multiplying whatever was outside, like the bracket, which is this 2, multiplying it with the small 2 here, gave us this 4. And the bigger 4 is the same as this 4. Okay? We just brought it outside at the answer. So 4 raised to the power 4 is 256. Now, how about when you don't just have a number or a letter, but what if you have a number and letters inside a bracket and is raised to a certain number, which in this case is 2? So what you do is start with this 4. What is the exponent of 4? I want you to remember that, like I told you before, if you don't see an exponent there, it means the exponent is 1. Okay? So when you multiply the 2, so 2 multiplied by 4's exponent, which is 1, equals to what? It's equals to 4 squared, because 2 times 1 equals to 2. Okay? Now, you multiply again this 2 multiplied by x exponent. Now, what is x exponent? There's also nothing written, so it means the exponent is 1. So what is 2 times 1? It's 2. So we get x raised to the power 2. Okay? Now, when we come to x, to y, when you multiply 2 with exponent of y, which is 2, you get a 4. Okay? So our y's exponent becomes 4. Okay? Now, when you look at the number part, remember guys, like in here, the number part was raised to a certain number. And to simplify it, after simplifying it, we came to 256. Now, when you look at this answer of yours, it's correct, but not in its simplest form, because we have 4 raised to the second power. So what should we do? We should simplify this 4 raised to the second power. So what is 4 squared, or 4 raised to 2? It gives us 16. So this one stays the same. And that is your final answer. Okay? Let's take a look at another example. How about when they are like in fraction form and they are raised to a certain power? What do you do? Now, number one, take a look at the exponent again outside the brackets, okay? And the exponent of whatever is inside of the bracket. Like the law says, we need to multiply the exponents. Now, this 2 multiplied by this 2. What is 2 times 2? It's 4, okay? So that's why we have m raised to the 4th power here as the answer. Now, if you look at your denominator, x raised to the power 3, what is 2 multiplied by 3? Why are we multiplying them? Because they are the exponents. Remember, the law says we need to multiply the 2 exponents, which is outside of the bracket, and the exponent of whatever base is inside of the bracket. So what is 2 multiplied by 3? 2 times 3 is 6. So that's why we have x raised to the power 6. And this is your final answer for this one. Okay? Let's take a look at another question again that has fractions and not just letters, but also have letters and numbers. So now you say 2, you look at this 2. Now inside the bracket there is also a 2. And remember what I told you, once there is no exponent, it means that it's raised to the power of 1. It's raised to the power of 1, okay? So what is 2 times 1? It will still be 2, like 2 raised to the power of 2, because 2 times 1 is 2. Now what is 2 times 4? It's 8, okay? So now we look at the denominator. What is 2 multiplied by the exponent of 3? Remember, 3 here has no exponent, meaning the exponent is 1. So you say, what is 2 times 1? There's always an invisible 1 there. So what is 2 times 1? Equals to 2. Now when you look at the exponent of x here, it's 2. So what is 2 times 2? It's 4. That's why in our answer here, we have 4 as an exponent of x. Okay? Now remember, like we did here and here, you can't leave this 2 raised to the power 2 and this 3 raised to the power 2 like this in the answer. You need to simplify them. So if we simplify 2 raised to the 2nd power, it becomes 4. And when we simplify 3 to the 2nd power, it becomes 9. Okay? So the letters stays the same with their exponents. So this is the final answer. Now in the previous video, I announced that you could win like 10 airtime, 10 Namibian dollar airtime, regardless of whether it's MTC or TN Mobile. Now in this video, I announced the winner. So what the winner had to do was subscribe and comment something positive within the previous video. So the winner of the airtime is Angula Yambo, who commented, "I am here since March. Your videos are really helpful and the quality is very good." Now if you find these videos helpful, which I believe you do if you made it until this part of the video, please do give it a huge thumbs up. Subscribe to the channel so that you don't miss the next upload. Turn on the notification button to be the first to see the next upload. Share with friends, family, and classmates. And remember, together we rise to higher heights. Apart, we all stay behind. Cheers.